So I'm gonna bring a question. I think I'm not sure whether we've looked at this particular question. Please just concentrate, okay? So, did we look at this question during the last class? This particular one?
No, sir.
Okay. So I'm going to be starting from Mercy this time around, then Sarah, then Moses. Okay.
Sorry, sir.
Sir, we are four.
Okay. Who's the fourth person?
She's Mercy is not here. She
Okay.
went somewhere.
Okay. Will she be joining us soon?
No, not
No, she's
today.
not joining us today.
Okay. Fine. Who is the third person there for today?
Agi.
Sir.
What's your
My name
name?
is Tayo, sir. I
Can you spell it?
Tayye.
Okay. Taye,
Taye.
right? Taye or
Yes,
or
sir.
Taiwo. Taye. Okay.
Yes,
So
sir. Tayo, sir.
yeah.
Yes, sir.
Now, let me be start. I will start from Messi, then Moses, then Taye. Okay.
Ah,
Hmm?
you just said Mercy is not going to be
I
here.
mean Sarah.
I just said Mercy is not going to.
Sarah. So Sarah, then Moses, then Taye. So Sarah, look at this question. Okay.
Oh, Jesus.
No, no, just calm down. Just look at it, and if you don't know what to do, you talk. Okay. Yeah.
Seems good.
So what do you think? Any idea, Sarah?
So wait, oh, there is.
Okay. Okay.
So I'm looking at C.
C, right?
Yeah.
Okay, you said,
So
hold on, you said R will form an
an
electrovalent bond
electrovalent bond with S.
with S. Okay, hold on. This is the third one, R, which is this one, right?
15.
So
15. Yes.
hold on. Let's just check it, okay? R equal 15, which is 2, 8, 5. So this 5 is 5 electrons in the outermost shell, okay? Then S is the last one, which is 17. That is 2.
Excuse me, sir.
Hold on, calm down. 8, 7. So this is 7 in the outermost shell, okay? There is no way this will form electrovalent bond with S because electrovalent bond involves transfer of electron, okay? And this is not ready to transfer just one electron. Is that clear? Is that clear?
Yes, sir.
For electrovalent bond to be achieved, you have one electron in the outermost shell. So Moses, you wanted to say something.
Sir, yes. Never mind.
Okay. Now let's consider option D. Okay. Q equal what?
Yes, sir.
11, right?
Q is 11.
Yes, that's it.
Which is 2, 8, 1. So this one electron outside means ready to give away, okay? In order
Yes.
to make the octet rule, so it will remain 2 comma 8 when it gives this one away. And if it forms a bond with S, that is 2, 8, 7. This one is requiring one electron, needing one electron, okay? While this one is giving away one electron. So this one electron will be transferred to balance with this. Then this one will become 2, 8, 8. So, and that is electrovalent bond, okay? Electrovalent bonding,
So,
which involves the transfer of, so the correct option is D. Is that clear?
yes, sir.
So, what this is telling you is that you should go into your book and study about chemical bonding, okay?
Okay, sir.
Go and read more on chemical bonding and types of chemical bonding and the conditions for those chemical bonding to take place. Why will electrovalent bond not take place in certain situations? In what situations are we going to have dative bonding? In what situation are we going to have what is called maybe hydrogen bonding? There are some kind of other bonding that goes beyond just electrovalent or covalent or coordinate uh, bonding. Is that clear?
Yes, sir.
So you have a lot of work to do under that. I mean, even if there is no class, just determine I want to read on chemical what?
Bonding.
Bonding. So take note of that. So again, I sent the notes yesterday, but I didn't send the yesterday's video. But I'm going to send it today by God's grace, okay?
What is in it?
All right. So the next question,
So,
you want to say something?
it's going to send it to me. So,
You want to say
Go
something?
ahead.
Go,
yes,
yeah,
sir.
Taye, you can speak, yes.
I was thinking that maybe you can send it to me too.
Oh, don't,
Yes,
to you, right?
yes, sir.
I think there's a dedicated number that I will send it to and they will get it across to you, okay?
Yes, sir.
So I will inform the person to send it to all of you so that at least you can prepare or practice with it. Even the previous one, which is the mathematics and chemistry and physics, you can get it, okay? Yeah. So the next question. So with this, we say electrovalent bonding involves transfer of electron, and since Q has 11 electrons with the configuration 281 that we can see here, okay, is that clear?
Yes, sir.
And it has a valency of 1. What's the meaning of valency? It means the electron in the outermost shell, and that is what designates Q as a cation, okay?
Okay, sir.
Uh,
Yes.
so, and this S, though this is not the name of their elements, they are just representing them with alphabet. S is 287, which is 17, which means it has a valency of 7, and it is requiring 1. That is an anion. Okay,
Yes. Anion.
good. So, and if there is any other information you want to know about this, Q is an element in group 1 because of the 1 valency. Okay, okay.
Yes, sir.
And S is an element in group 7 because, and without a doubt, Q is sodium and S is chlorine. Is that clear?
Yes, sir.
Why is Q sodium? Because the atomic number, which is the total number of electrons, is 11. Okay. Okay.
Yes, sir.
Then why is S chlorine? Because it has 17 according to the question. So if they ask you to name all of them, just check the number of electrons, then you are good to go. Like 6. Which one is 6? That should be carbon, right?
Yes.
Which one is 15?
Like,
Which one
R
is
is
Phosphorus.
15.
Phosphorus.
no,
phosphorus.
I mean phosphorus. Yeah, the real element. That's what I'm saying. Phosphorus.
Oh,
Okay, so let's look at the next question. So that will belong to Moses to just try a bit and see if he gets whatever the question is trying to bring out. Remember, when you see questions, it's just like it's just testing whether you have studied or you know what it is all about, particularly with topic and so on and so forth. So this one is trying to ask something which I'm going to bring the options down there now. Let's see. So, so these are the options. Over to Moses. Yes, over to Moses.
So, E.
What do you call it?
Law of definite proportion.
Law
hmm?
of
No, A. What?
multiple proportions.
Mm,
Multiple proportions, right?
yes, it's correct. Hmm, it's true.
Okay, that's correct. Okay. Law of
The answer
multiple
is A.
proportion. Law of multiple proportion. Okay.
Said it. Yes.
And it expresses, it states that if two elements A and B combine together to form more than one compound, just as this case, a compound HCl4, HCl3, HCl2, it said the various masses of the element B, which combines with a fixed mass of element, uh, the first one is fixed, which is XXX, while the next one is Cl4, Cl3. So they do so in a simple whole number ratio, okay? And you can see this 4, 3, and 2. So that's why we can say it is multiple proportion, okay? Is that clear?
Yes, sir.
Okay, let's bring up the next question. Hold on.
I'll press enter.
The next one
Press, I do
is
press it.
for Thai, okay? So here's the next question. So, Thai, just check this question
Sir,
and
it's
see
plus 5.
plus
Sir, plus 5.
plus 5, right?
Yes, sir.
Okay. So how did you get plus 5, or did you just choose plus 5?
Sir, I've seen the question before.
So can you explain it?
Um, I think I don't really know how to. I don't know.
Potassium chloride is +5.
It's plus five.
How? Can you explain how? Hmm.
How do you know?
Sarah, you too, how?
I'm not the one that said I know it. Though.
No, I thought you said something now that chlorate is 5.
I think
It's +1.
So now let me explain, sir. I don't know if
Okay.
it's plus five.
it's
And
plus
in potassium chloride, so that's KCl. So you have to look for the oxidation state of Cl in KCl. That means you have to know the oxidation state
No
of
KCS, KCS. Okay,
potassium,
yes,
and
KCS.
then you have to find the because in KCl, I think everything equals to I think minus two or zero. I'm not sure. So you have to find the oxidation state of chlorine in the equation.
Hmm.
Hmm.
Hold on. Hold on, just
Thank you, Joseph. Just do the answers. I didn't read the answers. I never liked it.
No, it's in the other in our test.
this thing I'm saying the question before.
No, it's one that did this.
It's not about gifts. It's not about gifts. That was that what this question came out in Jan.
hold on.
Then I was confused. It's plus five. So let's put this keyboard. Now we do not that they have. Moses say that
So like now, see this.
You cannot delete. Edit.
So, let me see this. Potassium chlorate. What's the symbol for potassium chlorate? The chemical symbol. Or like the chemical formula.
KCl.
Chem-
this
chemical formula. Potassium chlorate is what?
Symbol KCL.
KCl, right?
Yes. That's what.
Hold on. KCl is potassium chloride. Okay.
Potassium chlorate.
Yes.
Wait, I think it's
Potassium chloride is
KCRL.
KCl. Okay.
Yes.
So chlorate is what? K.
KCl5.
Oh, you're just putting the number anyhow you want. KClO3. Okay.
I
I
will
said you
finish
know
what
it.
I
You
didn't
lie,
read.
you don't know it.
Now, what is now the name of this compound?
Potassium trioxychloride.
Really? It's not a chloride, it's a chlorate.
Chloride, sorry.
Yes.
Potassium trioxychloride.
And the name is incomplete. You have to put this 5.
Potassium
Tetraoxosulfate.
No, wait a minute. You are right, Moses. But put the 5.
5
No, at the
potassium.
end, at the end.
Okay, okay. Potassium something. What you just
potassium
so
tri
potassium, what Moses said now, chlorate.
potassium.
O3 into brackets 2, into bracket 5.
Mm-mm.
potassium potassium trioxychloride 5.
Okay.
Eh?
Eh,
So how did he say?
Potassium trioxochlorate 5. Okay.
yes, sir.
Now, wait a minute. The question is we could have another name. We might not be sure whether it's 5, whether it's 3, whether it's 4, whether it's whatever. Is that clear?
Yes.
So it is this 5 that is the question that the question is asking you to find. It said chlorate what? Okay. And that is what you are going to get from the oxidation number as you explained. So if you want to know, it has to be neutral as a compound, okay? neutral charge. So it is the chlorine that is carrying the charge of this chlorate now, okay? So potassium there is positive 1, oxygen there is negative 2, then chlorine is what we are looking for. If we name it X, okay, we'll
Yes.
now add
Chlorine is what we're looking
we'll now add everything together to give us 0. So that means how many potassium is there? Only positive 1, okay? How
for.
many oxygen is there? 3 of negative 2, okay? Plus the chlorine, which is only 1, 2, then must give us 0. That means 1 plus negative 6 plus x is
Yes.
0. Then x will be equal to 6 minus 1, x equal to 5. That is why it is triacylchlorate 5, okay? Is that clear?
Yes, sir.
For example, if they ask you to explain H2SO3 and H2SO4 to explain tetraoxosulfate what, okay? Sulfate what? Is that clear now? You're going to use the same method. Hydrogen is what? Positive 1. Oxygen is what?
Positive one.
Negative 2 in both
Minus
cases. Then sulfur is what we are looking for in both cases. Not that sulfur does not have its own oxidation state, but the oxidation state will not be stable based on the valency of sulfur. Okay. Now we can now consider for this first one and say how many hydrogen? 2. That is positive 2 plus the sulfur plus the negative 6. Okay. Is that clear?
Yes, sir.
minus 1.
Hold on. I want to say the sulfur is SO32 minus. Hold on, let me confirm something before I. You sent a message before.
No, sir, it was a mistake.
Okay, okay, that
that
was a
was a
mistake.
mistake.
Hold on.
Makes sense.
So
Go here.
I want to.
Okay.
Okay.
So what do
Hold
you
on, just wait a bit before I continue. Then. Okay, so let's continue. Okay, so if we are trying to name this is going to be positive 2 of hydrogen plus what we're looking for sulfur and negative 6 of oxygen, right? To give us 0.
Yes.
So we now have
Let's go
2
there.
minus, that is minus 4, right? So x equal to 4, right?
Yes.
Right?
Yes, sir.
Then for the second part, which is this one, the hydrogen is 2. We're looking for the sulfur. Then the oxygen is minus 8, which is 0. So x here will be what? 8 minus 2, which means x equals to 6. So if we are naming this first one, if you are naming this first one, it will be tetraoxosulfate 4 acid. Okay, because of this 4. Why this one will be tetraoxosulfate 6 acid? Is that clear?
Yes, sir.
Tetraoxosulfate. So
Excuse me, sir.
yeah, okay. So that is, I'm just using that to show us what to. So the next question is going to come from uh, Sarah now.
Sorry, sir.
Yeah,
Please, can you?
okay,
I want to see what you are doing. I'm all right.
okay, yeah. So what I just tried to explain is that we use this oxidation state to name the compound, okay?
Yes, sir.
Okay, sir.
All right, so the next question is going to be, let's see.
Good.
So let's see. Okay, wait. Let me put that up again. So, Sarah, try to read this. Then I'll bring the options.
When air, which contains the gases oxygen, nitrogen, carbon dioxide, water vapor, and the rare gases, is passed through alkaline, pyrogalol, and then over quicklime, the only gases left are nitrogen and the rare gases. D.
Okay, nitrogen and the rare gases, right?
No. Um. God. Help me. So I don't think nitrogen is there. I think it's just the red gases.
The rare gases. And your answer is correct. Nitrogen and the rare gases, okay?
But you said well expression, so
But I said what?
the expression when I mentioned it, I had to change my mind.
I was only asking you now. So you should be sure, okay? Is that clear?
Yes, sir.
Now, for
Yeah.
quick explanation on it, alkaline solutions of pyrogalol absorb oxygen efficiently. So quicklime also have a strong chemical affinity to absorb water. So it will absorb the water vapor, and the other one will absorb the oxygen. Is that clear? So at room
Yes, sir.
temperature, calcium oxide, which is CaO, will spontaneously naturally absorb carbon dioxide from the atmosphere. So definitely with the quicklime that is passed through, so carbon dioxide has been absorbed, water vapor has been absorbed, oxygen has been absorbed, remaining only nitrogen and then the rare gases. Because why are they called rare gases?
What are they called? The red gases.
Mm,
Sorry, no. Where did I that video? I don't
mm, as in, or if I might say, I can say, what are the rare gases?
So they came out to
You said?
they pass out in the chemicals is the have oxygen within them.
Mm,
know.
oh boy, you will soon become a chemistry distant. Rare gases. Hold on. Read this, Moses.
So yes, that is good. It's not just a big picture.
Just wait a bit. Trying to do something. So I'm trying to ask a question here, right?
Yes.
I said you should. Number one, we were talking about,
Chemical bonding.
yeah, we're talking about energy, absorbed or given out, right?
Yes.
Good. So we said when heat is absorbed during a chemical reaction, that the reaction is said to be endothermic. And we said, what is an example of endothermic reaction? We said the action of methylated spirit on the palm, because it's going to make you feel cold and it takes heat from your hand, right?
Yes, sir.
And it evaporates or something like that. So we now said, what about boiling of water? Yeah, boiling of water is endothermic because it takes heat before the water can boil. It takes heat from the environment. Now, the same thing with evaporation of water and so on and so. But we're not talking about exothermic, the one that gives off heat into the environment. An example is when you detonate atomic bomb, it's going to create heat energy, though it's going to be destructive. Is that clear?
Yes, sir.
Then the combustion of fuel in engines is going to generate heat. Yes or no?
Yes, sir.
Like in your generator or in a locomotive machine like train and so on and so forth. Let's see uh, the next. I was also talking about energy profile. Okay, you
Yes,
need you need to
sir.
read up on energy profile, but basically, what we have on energy profile, let me see, is something like energy of the reactants compared with the energy of the products. Okay,
Yes, sir.
energy of the reactants compared with energy of the product. So we can have something like this. Maybe this is a profile. You know, this is the energy profile for, let's say this one is one of them, either exothermic or endothermic, and we try to duplicate it and have another one here, okay? So if you now want to describe them, we'll create energy part for our reaction. If the energy is starting at this level, let's say this is 5 kilojoule of energy, okay? And this is 10. Then this upper one is 15 kilojoules. I'm just giving example, okay? Then the same 5 kilojoule here, 10 kilojoules and 15 kilojoules. Now, if the reaction starts at if the reaction starts at 5 kilojoule, maybe it won't start until 5 kilojoule and reaches above 10 kilojoule, then ends here, whereby these are your reactants, okay, and these are the products. Is that clear? Reactants, then what? Products. This place is called activation complex, okay, and this place is activation energy. Activation energy. Are you getting this?
Yes, sir.
Since the reaction started at 5 and ended at an energy higher than 5, okay, because it's going to end here, and this place is higher than 5. Then we have this. Then let's consider the second one. It's starting at the same level, but goes up and now comes to end here. Okay, is that clear?
Yes, yes, sir.
Now, so what we want to figure out here is which one of them, because this is your A plus B and this is your C plus D. So what we want to figure out is which one of them, this is also the activation complex, then reactants, and the product. So this one is less than, the energy here is less than 5, right? Right?
Yes.
Good. And the
Yes,
energy
sir.
here is greater than 5, the energy of the product. Okay, so if energy is going to be released, it will be released from the one that is less than, that ended with less than 5, okay? Because let's assume this is something like 2 and this is something like 7. So the energy difference will be energy of the product minus energy of the reactant. This will be positive 2 kilojoules, okay? Is that clear?
Yes, sir.
Which means this takes positive 2 kilojoule from the environment, and that is why it is called endothermic. Okay?
Yes, sir.
But the other one that stops less than maybe at 2, so this is going to be 2 minus 5, and this will be negative 3 kilojoule. Okay?
Yes, sir.
Which means energy is given to the environment. Okay?
Yes, sir.
Energy, and we call it exothermic. Okay, exothermic reaction here, endothermic reaction here. So when you see an energy profile with an open mouth here, consider it as is taking energy from the environment. But when you see the one with a closed mouth here, like this going down, then it's going to release energy into the environment. Is that clear?
Yes, sir.
So for endothermic, we say change in energy, that is delta H, is greater than 0. While for exothermic, change in energy is less than 0. Okay? That's the energy difference that I just found. So that is where we'll be rounding up for today. I'm going to send this note, then I'll send the video too. Okay? So what you just
Yes,
need to
sir.
do is to make sure you read up on those topics: energy profile, what again? Maybe
Electrovalence bonds.
Atomic
Bonds.
bonding,
yes.
yeah, chemical bonding. Then you read more about,
Chemical bonds.
yeah, you read more about reactivity, reaction, reactivity series of gases or something, or elements. Let me put them that way. So that you know the ones that will react actively, you know the one that will not react at all. Okay? Is that clear? Then you read more also about oxidation and reduction, particularly oxidation state or oxidation number, and so on. So um, that'll be